Welcome to Future Talk. On today's program, we're going to talk about how to use modern technology to create livable and sustainable homes and offices that are highly functional, ecologically sound, and aesthetically pleasing. My guest is Terry Beaubois, an architect, researcher, and educator who's been involved in creating new architectural methods for many years. Terry was the founding director of the Creative Research Lab at Montana State University and directed the Ecosmart House project in Bozeman, Montana, which received the House of the Year award from the U.S. Green Building Council. He sees a connection between the habitats of manned spaceflight and the kinds of homes needed on Earth, and served as chairman of the Advanced Technology Application Committee, a joint committee of NASA and the American Institute of Architects. He's currently in discussions with the Stanford University Architecture Program about a collaboration to set up a community design and research center to advance his and the architectural program's ideas. Terry, welcome to the program. Good to have you today.
Thank you very much, Marty. It's a pleasure to be here.
Terry, what do you think is the broad direction of architecture in the next few decades? What are we heading toward?
Well, it's a really exciting time. I mean, I haven't felt this kind of energy in an area, both regionally and professionally, since the early days of Silicon Valley. I was here in the late 70s, early 80s, when there was a vibrancy and an explosion of innovation that we're going to see in the next couple of years here. It's already begun, but I think it's going to continue, and I think it's going to affect architecture and the design of buildings directly.
Now, you were involved in something called the Ecosmart House in Montana. What was that project all about? What was that attempting to show?
Well, it was a very, very comprehensive project. It was based on the idea that collaboration horizontally through the different disciplines, architecture, engineering, construction, and including government and the product manufacturers, the companies that are involved in the building, working together can create a project that is better, not easier. I often have people say, well, is collaborating easier? And I have to be honest and say that no, the reason to collaborate is because the project becomes better through that collaboration. And we did that with this project. The other thing is we had three specific goals for the house. One was that it should be sustainable. The second was that it should be low energy in its use. And the third was it should be designed for a disabled person because the daughter in the family was in a wheelchair. And so we took those three concepts and put them as major goals of the project. Many projects have one of those three, and we felt that by making it a collaboration and by creating those three goals, that it would be a real test of the team and our project.
Now, are you able to accommodate a disabled person without compromising on the features for people who are not disabled?
Yes. In fact, we did a couple of things. First of all, we hired the young lady who was in the wheelchair to work in our research lab to do some of the research in regard to disability design. And the interesting thing was she found things that I don't think a person who wasn't in a wheelchair would have found. We watched her do Google searches and we watched her search the internet, and she had a different approach. We all do when you really look at it. We think Google is one thing and you just put a word in and everybody gets the same return. But someone who's disabled, they have certain criteria and priorities that came out in her searches, and her contribution was significant to the project.
We actually have some slides showing the house. Can we see that first slide, please? Okay, so this is obviously the exterior.
Yes, this is a house in Montana. It's in a subdivision. It's actually a laboratory disguised as a house because it is a significant combination of mechanical systems and products that wouldn't normally be in one house.
Now, what are some examples of that? What's different about this compared to an ordinary house?
There were a number of things. One of the things you mentioned earlier, my involvement with NASA, it was really rewarding to watch a project and be able to incorporate a technology and windows that had been developed based on NASA technology from the 1970s that had been transferred to a company in Palo Alto, Southwall Technologies, and then eventually see it become used in this house. And it's significant in that it did, the space program forces a mission-critical approach to things, because you have to keep people alive. I think sometimes pushing the boundary, pushing the edge like that makes us all become very much aware of where the design can go.
You also have to save energy up there and not let it leak away.
Absolutely. One of the most interesting things I ever saw was a conversation in a space station design team, and you talk about a power struggle. That was the true sense of those words that I saw, where people were really struggling to get enough power for their experiments versus someone else getting that power, because there was a limited source of energy. So when you look at energy as a limited thing, as opposed to, well, we have enough energy, we just leave the lights on in the house, it's a completely different approach than when you're really trying to save as much energy by not using it as possible.
Let's go on to the next slide. All right, so that looks like the kitchen of the house.
Mm-hmm.
Okay, so what's different about this? How does this compare to an ordinary kitchen?
Well, you can see a couple of things just by first glance. One, the countertops are a really interesting material. It's actually a paper product that is impregnated with certain other materials, and it's made into a hard surface. So the countertop materials were very sustainable, recycled materials. You can see the windows in this picture, and you can see how they're not obscured by draperies or blinds because of the nature of the glass and the film that's in the glass.
What's different about the glass compared to ordinary glass?
Many windows have this feature, but we were able to custom design the film that's in the glass. It's in the between the layers of the...
You mean there are two panes in a space between the panes?
Yeah, there's actually three in this one. And it is actually able to eliminate the UV, which is the heat gain in the house. So one of the things that, whether it's in California or Montana or any other state, there's always places with beautiful views, and so people design their house for the views. And then often there is a impact from the sun, either in the morning or in the afternoon, the evening, sunset, so that it requires that people put the blinds down. So what we wanted to do was to create a window system where you could have the view all of the time and not worry about the solar impact.
You mean it filters that ultraviolet light?
It filters out the heat, not the light so much. So you could, we had an open house, and some people were sitting in the window seats, and a contractor came in and said, in my houses, if people were sitting in the window with direct sunlight on them, they'd be baking right now. And there was no heat gain, because that's the way the window was designed, not to have sort of random impact of heat gain at various times, but to keep the house sort of very, very tight. That's one of the new things about designing houses now. If you make them...
You also don't want heat to leak out of the house in winter.
Exactly right. In fact, they have this thing that we call the Ghostbusters gun, where they can go around the house and you can see where anything is leaking in or leaking out. And then you can seal these cracks, or you can mark them, and then the subcontractor can come in and seal the cracks. And that's something that we didn't have before. It's almost like you have the ability to see things that people couldn't see before.
I understand that there's a lot of work being done these days in materials research, putting together materials that have different or maybe better properties. Do you use any special materials in this kind of house?